we go. We're on the last section of Unit 5 on graphing linear equations. Today we're going to be talking about graphing in standard form. Okay, standard form of a line is this equation where you get x and y on the same side. Okay, it's kind of odd that way because it's the only one that deals with x and y being on the same side. Okay, now some of the specifics of standard form are that a and b cannot both be 0. One of them could be 0, and that's either going to give us a horizontal or vertical line because we'll only have one variable. Remember, any equation where you only have one variable, you automatically know is either horizontal or vertical. You have to test that out to figure out which one it is. But what we're going to be looking at here is a method to graph these. Now, I really like to graph in standard form. I'm going to say that we're going to graph using intercepts. All right. In last section we used the y-intercept, because we were in slope-intercept form. And so we use that y-intercept. Today we're going to use the y-intercept along with the x-intercept. And I want to look at it a little bit more in detail. So here it says the basics of the cover-up method. I'm going to look a little bit more closely at the graph. And just think about this. When does a y-intercept happen? We know about y-intercepts because we dealt with them in the last section. But when does a y-intercept happen? Okay, well, it happens when there's no movement on the x direction. Okay, so that means that x equals 0. So we find a y-intercept when x equals 0. Well, the same thing holds true for x-intercepts. To find out where this line will cross the x-axis, the y value is 0. It doesn't move any up or down. It's on this horizontal axis. Okay, so it's kind of backwards, but if you think about finding the y-intercept, all you need to do is set x equal to 0. If you want to find the x-intercept, you set y equal to 0. That's the backwards part of it. And we have some specifics here, but for the most part, if I want to find, to find the x-intercept, I'm just going to say the x-int, we want to set y equal to 0. Okay? And basically that means to cover up, and this is the way that I use it, cover up the y term. Okay? If I were solving this equation up above here, and here I wanted to find the x-intercept, I want to set y equal to 0. Well, whenever I multiply 0 by anything, so if I had something like ax plus b times 0 equals c, well, that b times 0, that's just going to go away, basically. Anytime you multiply by 0, it goes away. So what I do is sometimes I get fancy and use a little piece of paper for this, or other times I just use my hand, and what I do is I cover up that term. That piece of paper is too big. Great idea, didn't work out. Okay, I'll cover up that b or that y term, and I'm left with ax equals c. All right, and that's why I said most of the time I just use my finger. Okay, so ax equals c. Now I know, now I can solve for something. And we'll get using that here in a second. Let's go ahead and finish this idea. So this is to find the x-intercept. So the opposite is true for the y-intercept. So to find y-intercept, so to find that y-intercept, we're going to set x equal to 0. All right. And really what that means is to cover up the x term. Again, because we'd be looking at a times 0 plus by equals c. And that's why we use the cover-up method, because it, covering up those terms makes it an easier equation, and it makes it to where we can solve it. So let's look at an example here. I'm going to try to make my little piece of paper here work. So I want to graph using standard form. So what I want to do is I want to, first of all, cover up each term and figure out what the intercepts are. So let's find the x-intercept. So x-int. To find the x-intercept, I set y equal to 0, cover up the y term. All right? So I have 3x equals 6. And then I just rewrite that. 3x equals 6. Okay? And now I just solve for x. All I need to do is divide by 3 on both sides. And x equals 6 divided by 3. That's right, negative or positive 2. Yeah. And then to find the y-intercept, we'll find both the intercepts, then we'll graph using that method. To find the y-intercept, cover up the x term. Okay. Make sure that you do leave whatever sign goes with the variable. That's important. Sometimes that might be a minus sign, and that means it goes with the y. It doesn't go with the x, though. Okay. So negative 2y equals, why am I stuck on negatives? That's a positive 2y. So we have 2y equals 6. Okay, don't be thinking too hard here. Divide by 2 on both sides. Y equals 3. All right, so now I'm going to use those in order to graph this line. So I have an x equals 2, and that's telling me my x-intercept is 2. So x-intercept, that's where it crosses the x-axis, is at 2. The y-intercept's at 3, where it crosses the y-axis is 3. I have 2 points, and I only need 2 points to draw a line. So there we go. We are set here. Couldn't be easier. Hopefully you agree at least somewhat that that's not a bad method, as opposed to, the method that always works if you don't know how to graph something is to make a t-chart, make a big table, and plug in a bunch of points, and that just gets ugly after a while. All right, let's find a quick key here for finding intercepts in standard form, and this is the one thing that I love. Since we're dealing with ax plus by equals c, and to find my x-intercept, we said cover up the y term. Okay, cover up the y term, that by is gone. So my x-intercept, I have ax equals c. And to solve for x, I divide by a, and we're left with x equals c over a. And that's something that you can always use if you can remember it. If not, go to the cover-up method. It's always going to work also. But really all I have to do, let's check that with the one I just did. Finding the x-intercept as c over a, 6 over 3 is 2. Okay, it's what I end up doing anyways, but sometimes people don't remember if x-intercept is c over a or b over c or whatever. So if that starts confusing you, just go to the cover-up method. It always works. All right, so to find the y-intercept, you cover up the x term, and we get by equals c. by equals c. Divide by b on both sides. Okay, so I've divided by b. Those cancel. I get y equals c over b. So if you can remember those two, maybe put those two over here in the question column. Make sure you know those are important. If you can remember them, it does make life a little bit quicker. Let's see an example of how that makes life a little bit quicker. I'm going to need a calculator on this one. I can already tell I have some big numbers here. All right. So x-intercept is C over A. All right, C is 112. A is 7. 112 divided by 7 equals 16. Y-intercept, that's going to be C over B. 112 over, hold up, we have a negative 8 here. That's not just a positive 8, that is a negative 8. And that's going to give us a negative 14. Okay. So those are my answers there. We're going to spend a little bit of time here just finding intercepts, and then we'll go on to graphing. All right. So let's go ahead and get these 3 problems down here at the bottom done. Maybe I'll do one and let you do one, or I'll do 2 and let you do 1. That sounds pretty good. All right. We'll find the x and y intercepts. X int equals C over A. Okay, what's going on here? I have a 0 for C. There's no number for A. Remember, there's that ghost 1 there. Whenever you have a variable by itself, there's always that ghost 1. It does exist. It is there. Don't get thinking it's not. Okay, so I have 0 over 1. I can go 0 divided by a number. That's going to give me 0, and I'm good to go. Okay. So the x-intercept's 0. Y-int, C over B. C is still involved, and it's actually the same setup. But so we have an x-intercept of 0 and a y-intercept of 0. Kind of a boring line, but it's okay. It all works out in the end. All right, let's look at the next one here. X-int, Y-int, C over A for X, and C over A is negative 6 over 1. Remember, there's that 1 in front of there. And C over B, oh, I guess I could simplify that. Negative 6 over 1 is negative 6. And C over B, that's negative 6 over 2. The number before the y is a 2. And that's going to be a negative 3. So this has intercepts of negative 6 and negative 3. Go ahead and pause the video and get that last problem over here done. Alright, welcome back. Hopefully you had a chance to get that, and hopefully it wasn't too taxing on you. I know that this doesn't come out to be a round number. At least one of them doesn't. Because I can see right now, for the x-intercept we have C over A. C is negative 12 and A is 7. Okay, I know those two don't divide into each other evenly. So, I mean, if you want to say negative 1.71, that'd be okay. If you wanted to leave it as the negative 12 over 7, that'd be okay also. Yikes, you didn't see any of that. But, you know, if you want to leave it as the negative 12 over 7, you can, or the negative 1.71. It doesn't really matter to me. I know what you're talking about. All right, here we have C over B. C is negative 12. B is negative 4. Negative divided by a negative will be a positive. 12 divided by 4 is 3. All right. That's not too bad. Okay, let's go ahead and move on. Next page. All right, we're going to be looking at graphing using these intercepts now. Okay, hopefully we can get pretty quick at finding these intercepts. Again, if you have to use the cover-up method, there's no problem. There's no shame there. Just do it, get it done, and make the problems work for you. All right, so here we have x and y intercepts. X-intercept, I'm just going to write it up top so that I have it. And I'm just going to say x equals C over A and y equals C over B. So I don't have to keep rewriting that on every problem. I just want to refer to that. All right, so x-intercept is C over A. C is 1, A is 2, so that's 1/2. Y-intercept C over B. C is 1, Y is 1. So that's 1. 1 divided by 1 is 1. So the x-intercept is 1/2. That's kind of tough on this graph, but that's okay. And the y-intercept is at 1. So we have 2 points that are pretty dang close to each other. We can still estimate what a line would look like, but we don't know that's what it's going to be. Anytime you only have 2 points, yeah, you have one line, but you know how we are with the human error issue. We can always, I'm betting mine's off a little bit. It's probably too far that way. But oh well, it works. Yeah. All right, let's move on. We got to get through these kind of quick. So we have -10 as C. So -10 divided by 2 is -5. -10 divided by 5 is -2. So an x-intercept of -5, y-intercept of -2. You have your 2 points. You can draw your line. And keep in mind, I'm still asking that you cover all of the graph with the line. Don't be lazy. All right, C is 5, A is 1. So 5 divided by 1 is 5. C is 5, B is -1. That negative there makes this a -5. Not a big deal, right? It actually makes it okay. So the x-intercept is 5, the y-intercept is -5. Again, it'd be wonderful if you saw any of that. Hopefully that made sense, though. We have this ghost 1 in front of there and a ghost 1 in front of there, but this one's actually negative. So the y-intercept is 5 over -1, which gives us a -5. And there we go. We have our line, and we are good to go. If you need some extra time to fill that in, go ahead and pause the video and check it out. But right now what I want you to do is pause the video and try these these three problems, and then we'll wrap it up with some extra stuff. Okay, welcome back. Hopefully you got a chance to get those done. Here we have C over A. That's -12 over -3. That's going to be a 4. And -12 over 6 is a -2. So x-intercept of 4, y-intercept of -2. I have 2 points on the graph. That's enough for a line. Oops. I don't know what that was. Okay. Next one we have x-intercept at C over A. -4 over 4 is -1. And -4 over -1. Remember that 1 is there. If you always have to write it, that's okay. You can do that. -4 over -1 is 4. So -1 and 4. Once I have 2 points, I can draw a line. The only downfall to standard form is it doesn't really tell us if we wanted to make another point. It doesn't really tell us how to do that. It doesn't necessarily give us slope. It does in a way because you have graphed the line so you could find the slope, but it doesn't give it to us explicitly. So this one we have C over A. That's 12 over 3, which is 4. And this one's a little bit ugly. It's 12 over -9, which is, I'm just going to say -1.3, repeating, or -1 1/3. Okay, whatever helps you to graph that. It's not going to be, it's not going to be great, but we can make it work. So an x-intercept of 4 and a y-intercept of -1 1/3, somewhere in between 1 and 2, preferably closer to 1. And that'll be enough to make Mr. Gall know that you're at least trying to get those numbers in the right spots. I know that it's not easy, especially when we got these little dinky graphs on here. The main reason for that is so I could fit more problems without having to 12-page packet. I know we all like that last one where it was just a 1 page of notes, but they can't all be like that. All right. So hopefully you got a chance to get those done and correct, I'm hoping. But if not, you can either try to fix your mistakes, figure out what you did wrong, or talk to me and I'll help you out whenever I can. Let's wrap this up with a little talk on horizontal and vertical lines. This will only take a second. So when we're dealing with horizontal lines, let's just focus on one at a time. So horizontal lines. The equation is y equals a number. This might as well say a number. Okay? Y equals a number is a horizontal line. I don't have a great way for remembering this. All right? If I was being quizzed on it, I'd definitely put it on a note card or something, whatever I was allowed to use. And I'd try to make that commit it to memory. The main thing I look at is if y equals -3. So I know that y equals -3. And, this might not make sense to you. And if it doesn't, then it just doesn't. You'll have to find a different way. But I look at y equals -3 and then maybe, well, what about y equals -2? So I know that this isn't a point on my line. But I think of if it was through y equals -3, would a vertical line make sense? Because y equals -3 needs to be different from y equals -2. Well, if y equals a number meant vertical line, then y equals -3, y equals -2, y equals -1, y equals 0, all those would be the same vertical line. But as I look at it, they're all different horizontal lines. Okay? So that's kind of the way that I use. It's not perfect, trust me. I feel like it causes me to think way too much. So if you can find another way, I'm all for that. If you've been taught another way and you'd like to share it, feel free, okay? I'm definitely open for stealing stuff from other teachers or whatever it may be. Just the way that they say it sometimes works better. So this is a horizontal line through -3. That's all we need to know. Y is horizontal, okay? And it's just kind of backwards because we think of y as being the up and down. But basically you go up and down until you get to that number and then draw a horizontal line. For the other side of that coin, all right, vertical lines have the equation x equals a number. So notice here that we only have one variable in our equation. This is the equation. I know it feels kind of dumb, but that's the equation of this line. All right? And anytime you have x equals a number, we get vertical. So again, I kind of think of x equals 4 and x equals 3. If it was horizontal, well, they'd be the same line, and that wouldn't make sense. They need to be vertical lines to where they're different. All right. So we get a vertical line. Let me draw it and I'll show it. Wonderful vertical lines. Actually did pretty good on keeping it on the grid line there. Trust me, that doesn't happen all the time. So if you're having a hard time drawing that line, just take it from me. It's not that easy. So we'll look at a little bit of horizontal and vertical line stuff. It's just something that, whenever you're talking about equations, they're going to ask you about, and you just have to find your way to keep those two things straight. And yeah, whether it's write it down a million times on note cards or find some stupid little saying or something that works for you, you don't have to share it with anybody, all right? If you care to share something that helps you out, feel free. I'm always receptive. But so this video got a little long. Sorry we had to cover a lot of stuff. You guys did great, though. Good luck on the practice, application, and mastery challenge. We'll see you out there. And now for our last kid snippets, we're going to find the number 1 video. It does fit because we are talking math, but the number 1 kid snippets video, math class. It's a good one. Enjoy it. And
I think it's already starting. Okay, here's your homework. First let me tell you the directions. What's 4 take away 5?
1, 2, 3, 4, 5, 6.
Take away. What's 6 take away 1?
1.
No, you take away, so you take away 1 out of 6. How much does it equal? What's 10 minus 1?
I don't know.
1, 2, 3, 4, 5,
6.
6, 7, 8, 9,
10.
Nope. Take away 1. How much is it?
1, 2, 3, 4, 5, 6, 7.
Nope. 1,
2, 3, 4, 5,
6,
6,
7,
8.
8. And one more. And add 1 more. How many does it equal?
1, 2, 3, 4, 5, 6, 7, 8. 1.
It makes 9. See how you take away? You take away 1 and it equals
1.
Do you get it now?
Yes.
Try again.
1.
3. Yes. Good job.